Hey there, Mr. Weaver here, and this is Topic 7, Lesson 6, Special Cases in Factoring. After this lesson, you need to be able to factor polynomials that are considered special cases. You'll know you're successful after this lesson if you can use patterns to factor perfect square trinomials and differences of two squares. In this lesson, you are going to see two types of what are called special cases. So the first type is called a perfect square trinomial. Now, this one you can factor just like the other ones in the previous lesson, but these do follow a specific pattern. A perfect square trinomial is the result of squaring a binomial. That just means that you're going to end up with the same thing both times. So for these, they follow the pattern where the first number is squared, so a squared, the last number is a perfect square, and the number in the middle is 2 times a times b. The only difference in the two formats is one is going to be positive, one is going to be negative. You might not recognize these as you're going through until you get to the end in factoring. Just know that they do follow a special pattern. Once you're done factoring, these are going to end up in one of two formats, either a plus b to the second power or a minus b to the second power. And in our examples, we will say x instead of a, and then instead of b, it will be a number. Our other special case is called the difference of squares. So this is going to also deal with two perfect square numbers, but it's always going to be a squared minus b squared. It's subtracted. There is no middle term in the difference of squares, which is one of the ways you can recognize it. When you factor a difference of squares, you end up with one factor is a plus b, and the other factor is a minus b, and when you connect them, you'll have essentially the same thing both times, but one is plus and the other is minus. Let's look at a first example. We have x squared plus 10x plus 25. Now, at first glance, it looks like any of the other simple trinomials that we did in the last lesson. If we look closer, we can see the hidden number in front of x squared is a 1. That's a perfect square. And 25 is also a perfect square. This is a perfect square trinomial. If we didn't see it, we could go through and still do our method. We would multiply to 25, add to 10. We can figure out our two numbers. This time, they are both the same, 5 and 5. That is the key here for knowing that it is a perfect square trinomial. You're going to get the same thing both times. Since this is a simple trinomial, we could just take those numbers and plug them in. Or we can use our area model. X squared goes in the top left, 25 goes in the bottom right. Both of our x factors are plus 5. If we find the GCF of the side and the top, like we did in the previous lesson, we can see we would get x plus 5 on the side and x plus 5 on the top. Again, it's the same both times, which tells us that this is a perfect square trinomial. So if I were to write that out, it would be x plus 5 times x plus 5. Now, because they're both the same, we can simplify this further. Anytime you have the same thing multiplied by itself, you can write it with an exponent. So this would be better written as x plus 5 to the second power, because x plus 5 is there twice. Again, had we just used the fact that the number in front of x squared was a 1, we didn't really need to go through all the boxes. We could have just plugged in the plus 5 and the plus 5. Either way, we get the same answer. Now it's your turn. Pause the video, factor this perfect square trinomial. Let's check. You should have got x plus 6 to the second power. If we look at our values that multiply to 36 and add to 12, it's 6 and 6, which means we ended up with x plus 6 both times. So simplified would be x plus 6 to the second power. Let's look at another example. So x squared minus 6x plus 9. This one looks a little different. We have that minus 6x in the middle, but again, this is a perfect square trinomial. The first number in front of x squared, 1 is a perfect square, and 9 is a perfect square as well. For this one, I'm going to use the fact that a is 1, so I'm just going to find my factors, multiplying to 9, adding to negative 6, which means negative 3 and 3. Which means negative 3 and 3. Again, don't be afraid to use Desmos to help you figure out those factors. And if you don't remember how, go back and look at lesson 5. This time, I'm just going to plug them in, x minus 3 and x minus 3. But since they are the same, we do need to simplify it further to x minus 3 squared. If we wanted to use the boxes, we could have plugged in our values, found x minus 3 on the side and the top. Either way, we're going to get the same answer. Now it's your turn again. Pause the video and factor this trinomial. Let's check. You should have found x minus 12 to the second power. Looking at our values, we would get negative 12 and negative 12 that add to negative 24 but multiply to 144. If you chose to use the box, this is what that would look like. Getting x minus 12 on both the side and the top. So x minus 12 squared. This next example is the difference of two squares. If you notice on this one, there is no b term. So essentially b is equal to 0. If you wanted to rewrite this so it was a trinomial, it would be x squared plus 0x minus 25. What this means in terms of our factors that we need to find, they would multiply to 25 but add to 0. Now, if you're trying to get two numbers that add to 0, that only works when they are exact opposites of each other. We could go to Desmos and just use that and figure out the two numbers, but what number times itself would give you 25, and then they would have to be opposites to get to 0. So they would end up being negative 5 and positive 5. In this special case, it's going to be the same value, but opposite signs of each other. So here, minus 5 and plus 5. For this one, since the value in front of x squared is a 1, we can just plug in the minus 5 and the plus 5. So x plus 5 and x minus 5. If you chose to use the boxes, that is fine, but I'm not going to go through that here. Now it's your turn. Pause the video, factor x squared minus 64. Let's check. You should have got x plus 8 and x minus 8. The two numbers that multiply to negative 64 but add to 0 are positive 8 and negative 8. So we would plug those two in. Since this is simple, meaning the number in front of x squared is just a 1. Our last example here is another special case where it's the difference of two squares, but it's more complex because the number in front of x squared is not 1. There is still no b term, which means that b was 0. So if we want to write it as a trinomial, it would be 4x squared plus 0x minus 9. Then thinking back to last lesson, when we had the complex trinomials, in order to figure out our values, we needed to multiply a and c. So 4 times negative 9 is negative 36. So when we're figuring out our values, they need to multiply to negative 36, but add to 0. Just like before, they are going to be the same number, but opposite signs. So here it would be negative 6 and positive 6. Now, thinking about what we did before, with the complex ones, we took our first number and our last number and plugged them into the appropriate boxes. We took our two values that we found and plugged them in the other two, and we found the GCF of each row and each column. Here I end up with 2x minus 3 and 2x plus 3. Notice, just like in the last example, you still end up with what looks like the same binomial, except one is adding and one is subtracting. So I have 2x minus 3 and 2x plus 3. They look the same, one's add, one subtract. One of the cool things about these special cases is even if it's a complex polynomial here, they still follow patterns. If you notice, that first term, because it had to be the same both times, to get 4x to the second power is the same as 2x times 2x. That minus 9 is where they need to be opposites, so plus 3 and minus 3. Essentially, if you just take the square roots of those numbers, so the square root of 4 is 2, the square root of x squared is x, the square root of 9 is 3, you're going to get your values and then just make one of them plus and one of them minus. So now it's your turn one last time. Pause the video. What are the two binomials after factoring 16x squared minus 49? Let's check. You should have found 4x minus 7 and 4x plus 7, or you could have switched them around. We'll go the short way on this one. 16 is 4 times 4 with the x's to make x squared, and 49 is 7 times 7. Just make one positive and one negative. You end up with 4x minus 7 and 4x plus 7. If you wanted to go through the other process, you are more than welcome to do so. In this lesson, we learned about factoring special cases. These are just certain formats that you see where either they have the same factor both times or they look the same but opposite signs. And these special cases follow the same patterns each time. So if you can learn to recognize these special cases and know what patterns to use, these can become pretty quick to solve. When you're factoring a perfect square trinomial, which was our first special case, it results in the same factor both times. So we would write it as x plus the number or x minus the number to the second power, instead of writing out the binomial twice. Our other special case was called the difference of squares, and this one appears when there's no b term, because the two values canceled each other out. It only shows as ax squared minus c. When you factor this, you get essentially the same binomial both times, just one's plus and one's minus. And with the difference of squares, there is a quick trick. Just take the square root of a, you'll get your first value. Take the square root of c, you'll get your last value. Make one of them positive, one of them negative, and you will have your two binomials. So after this lesson, do you now know how to use the patterns involved for special cases to factor, including perfect square trinomials and the difference of squares? If you're not sure about those things, go back and look at the first two examples for perfect square trinomials and the last two examples for difference of squares. Rewatch these to help deepen your understanding of those two concepts. And that's the end of lesson 6 on special cases of factoring.